Hello. Today we are solving a complex familiar question. So it's a application of a rates of change. Now, this is a very interesting question about volume. So water tank question. So let's have a look at the question. So I'm going to share this. All right, this is the question. We have a water tank. So water is drained from the cylindrical water tank. So at that moment, the height of the water is given by this yellow formula, highlighted in yellow. You can see we highlighted in that yellow. And also the original tank, the diameter, sorry, the radius is 1 meter and height is 2 meters. So the tank is full and T was 0, isn't it? So we times 0. So that means we need to, first, we need to determine what is the time taken to empty the water tank. So what's that mean? So we need empty water tank means the height of the draining height, I'll call HT. So we already given to equal to 0. So when T equal to what? Sorry, T equal to what? The HT equal to 0. So let's solve that. So we have, 9 divided by 2 divided by 9, 10 T plus 1 minus 1 equal to 0. So let's solve for the T. So which is pretty simple equation. So therefore T equal to 9. So we just, 9 minutes. So taking 9 minutes to put at that height of a draining height is equal to 0. So that means the water tank is empty. So question A is pretty simple one. Okay, let's do the next question. We found the magnitude of draining rates. So what we need to do is we need to find the magnitude of, so magnitude we know goes absolute value of dV and dt. Equal to what? So in order to that, we need to find out what is a VT first, draining. So we could draining volume. So let's do that. So to find the draining volume, we will be using that shaded area. So we know is the area base, which is pi r is 1 square times by height. So which is pi times by h is 2 divided by 9. So then we just put that. All right, so let's simplify to 2 pi divided by 9. Actually, we're going to leave as like this fraction. So because we want to find a dV dt. So let's do dV dt. So dV dt, so differentiate that. So 2 pi over 9 will be leave outside. So we differentiate that inside a bracket. So that will be easy to do, I guess. That'll be negative 2 pi divided by 9 times by t plus 1 to the power of 2. Actually negative 20, is it? Because you got 10 here. Sorry, just go to negative 20. Oh, sorry, just doesn't like the 20. I'll just put it one more steps. So the negative 20 pi divided by 9. So this is the derivative, but an absolute value. So we just magnitude of that. So it will be positive. So that's the second question. So B. Okay, let's do the next question. Determine the exact magnitude maximum and the minimum. All right, so let's do the exact maximum minimum. So what I mean by maximum? Maximum means the denominator. So we say because the absolute magnitude of dV, the draining rate, is given by positive 20 pi divided by 9. So that's our, so to achieve the maximum value for that, that means T need to be minimum. So when the T minimum, which is when T equal to 0, so we means time equal to 0, so the denominator become smallest, so the total fraction become maximum. So therefore we substitute the maximum rate is 20 pi divided by 9 times by 1. So therefore the answer will be 20 pi divided by 9. So that's a draining rate. So it's meter per minute. So that's the maximum. So minimum is when minimum means the denominator has to be maximum. Denominator maximum means T has to be equal to maximum draining time, which is taken 9 minutes. We just previously, question 1, we did it. So when T equal to 9, we substitute. So the minimum draining rate will be 20 pi divided by, so 9 bracket 9 plus 1 to the power of 2. So the answer will be 20 pi, so that'll be 10, 10 will be 100, so it'll be 900. So the minimum rates will be this, so cancel that. So that's about pi over 45 per minute. All right, so that's the question C. Okay, let's do next question. We will say, if water is added to the top, so we're going to adding water, not draining only. So the adding rate, so adding, so the adding rate of change is adding rate of change is 1 meter per, oh sorry, it should be meter cube. So meter cube per minute. So then determine the time when the water level is lowest. So what I mean by lowest means you're adding water, same time you're draining water from the tank. So therefore we will see, so therefore let's find out the adding volume first. So therefore the adding volume is determined by the rates of change, which is 1 in relation to T. So therefore will be T plus C. Now because when you're adding a water at the beginning, When time equals 0, you haven't got any volume. So we substitute, so therefore we have C equal to 0. So therefore volume, the adding volume, so this is the adding volume equal to Vt equal to just T. All right, so this is the adding volume. So the draining volume, we already given in the previous. The draining volume, we in the previous equation, we already done, which is I'm highlighting. So let's highlight that. So which is this? I'm going to highlight that. So this is the volume for draining volume. So this is the VT. So I'm going to do, okay, 20, it's a 2 pi over 9. So which is 2 pi over 9, 10 divided by T plus 1 minus 1. So there's a draining volume. So the total volume, will be, so when you're adding and draining same time, so you put two together. So it'll be T plus 2 pi over 9, 10 divided by T plus 1 minus 1. So therefore, what is the lower, when determine how long it takes to the lowest level, so that means you need to find out the, so therefore, so we need to find out determine the time of when the draining is the lowest level. So let's have a look. At the lowest level, we know is the differentiation is must be equal to 0. So therefore, at the lowest level, so let's do that. So at the lowest level, so dV dt must be equal to 0. So that means because the lowest level means the rate of change becomes 0. So let's differentiate that. So we're going to, so therefore, so we say, so therefore 1 plus actually going to be minus, is it? So 1 take away, so that we know draining rates change is 20 pi over 9. Remember we just did a few minutes ago. So that's equal to, so that has to be equal to 0. So let's solve for the t. So therefore, we know the t plus 1 square must be equal to 20 pi over 9. So therefore, time must be approximately equal to, let's solve about 1.642 minutes. So that's the lowest level. So now determine volume of water tank at this lowest level. So therefore, we just substitute 1.642 into my volume equation, which is this one. So total volume. So we substitute to, so time is 1.642 plus 2 pi and 10, 1.642 plus 1 minus 1. So therefore, the volume is approximately equal to 3.586 cubic meters. All right, so that's the question D2. So D3, find the time taken. It takes the tank get it full again and begins to overflow. So what's that mean? So that means when the tank is getting full, so therefore the total volume should be when tank is full. So volume should be pi times by r squared times by the height, total height, which is pi times by r is 1 squared times by total height of the tank is 2 meters. So the answer will be 2 pi. So that's the full tank. So therefore, our total drain and adding the water, so the VT, so therefore VT must be equal to 2 pi. So therefore we, 2 pi. So therefore, so our volume formula was 2 pi divided by 9, 10 divided by t plus 1 minus 1 equal to 2 pi. So let's solve for the time. So this is the equation we have to solve. Obviously, we need to use the common denominator, simplify. So we will find a time equal to roughly, approximately equal to 5.981 minutes. So this is how long takes the tank getting full again, getting 2 pi. So lastly, we would find a constant rate to add it such that is full again at 9 minutes. So when t equal to 9, we want a constant rate. So let's say this constant rate is equal to r, all right? So therefore the dv, so constant rate is r, so dv dt is r, so therefore the volume, constant adding volume will be integration. So that's equal to RT plus C. Now again, we will determine T equal to 0, the constant volume must be 0. So therefore C must be 0. So therefore the volume, constant volume, the adding volume is RT. Okay, because time is 9, so therefore, so the constant volume, adding volume will be 9R. So let's substitute into the total volume formula. Total volume formula will be, so it'll be 9, so it'll be 9R plus, well, we got the 2 pi, 2 pi divided by 9, bracket 10, bracket t plus 1 minus 1. So time is 9, sorry, we'll put a 9 there. All right, so therefore we can solve for R. So this is when the full again means 2 equal to 2 pi, isn't it? So equal to 2 pi. So then we can solve for the R. So the R, solve this equation. So R will be 2 pi over 9. So that's roughly about 0. So that's the constant rate adding water is cube. So that's per minute. All right, that's it. We're solving those four questions, and this is a rates of change question. Sorry, my writing a little bit messy, and just try to see how you digest this whole solutions. Thank you for watching, and see you next time.